Yeah, hello everyone. Today I'll be teaching about how to plan a high tibial osteotomy using a bilateral lower limb standing scanogram. Now, this is a lecture dedicated purely for residents and also for orthopedic surgeons who are planning HTO either for themselves or for their faculty. And it has always been a question for me of how to plan the HTO because all the research materials and the papers talk about how to find out the correction angle. However, they don't speak as to why are we doing this planning and how to calculate the wedge size and what is the practical application of it for your faculty. Why is the faculty asking you to calculate that angle? A key concept to understand before we start planning high tibial osteotomy is the concept of the point that or what we call it as the target point of high tibial osteotomy. The target point is basically a point on the tibial plateau through which the weight-bearing axis passes. If we consider this as the weight-bearing axis and this is the tibial plateau, so this is particularly the point that we are trying to talk about. If we look at a pre-operative knee here, we can see that is frank varus and the weight-bearing axis is passing at the level of the upper tibial plateau way medially than where it should pass through. After correction, if we look at the same weight-bearing axis, we can see that it passes through the center of the knee joint. Now this is what the entire purpose of high tibial osteotomy is. We try to convert varus into slight valgus overcorrection where this point is converted into this target point, and this target point is the one that is going to decide our correction angle that we are going to calculate further as we plan the high tibial osteotomy. A very important concept that we also need to understand before we move forward is the concept that you might have read articles or you might have seen it in PPT or when your faculty talks that this target point is expressed in terms of percentages. So what is the logic behind that? Now if we look at this tibial plateau, we realize this is the medial side and this is the lateral side. Now these percentages are expressed in this regard such that the medial-most point on the tibial plateau is considered zero point 0 and the lateral-most point is considered 100. Naturally, the center-most point will be considered 50. So when I say that the target point, example, what we you might have heard this word Fujisawa point. So Fujisawa point is considered as between 60 to 70%. So when I say that, I mean to say that on the lateral condyle, if this is 50%, so approximately 60 to 70%. This is the area in which the Fujisawa point will lie. Now, previous recommendations were that in part of HTO we try to overcorrect you always try to overcorrect the varus malalignment into valgus malalignment. Now, this is done thinking that by overcorrecting it, there will be complete offloading of the medial compartment and the lateral compartment would bear the weight. However, recent studies have shown that only a slight overcorrection is needed because if you overcorrect the varus into valgus beyond a certain point, there is no improvement in the loading of the medial condyle and there is increased stress on the lateral condyle. So this is what something we try to avoid. So in our institute we believe in the same theory where the lateral most where the ideal point for us lies approximately between 55 to 60% on the tibial plateau. This is where the ideal point will lie, and important recommendation uh, and an easy way to or easy method to localize this point is particularly the apex of the tibial eminence. So if we look at here, this is particularly the tibial eminence, and this is the point that lies approximately 55 to between 55 to 60%. And as per a paper by Sir George Chahala, this is basically the point at which 56 this is the point which represents 56% on the tibial plateau, and hence we prevent overcorrection here by keeping this point as the target point. And this entire planning our target point for correction will be this 56% on the tibial plateau, rather than the previous overcorrected valgus points that we used to use as recommended by Fujisawa and others. Many methods by which you can find out the correction angle that we need for HTO, and or also whether to see that your surgery is going as planned. Now, with the availability of robotic navigated assistance, we also have navigated assisted HTO, which help us to predict the alignment perfectly intraoperatively. This is not the point of our discussion today. We'll be talking about the conventional methods that we use while planning HTO, and so that we don't overshoot or undercorrect our ORS deformity. And usually we believe in preoperative planning. Intraoperative methods, some surgeons prefer intraoperative planning rather than the preoperative planning. And intraoperative planning is also practiced by us, but it is just a measure of whether the surgery is going as planned. It is a corrective tool and not a planning tool as per us, and we use a radio opaque rod here, which acts like the mechanical axis, and we just see at exact what point is it passing through it. That is not what we are going to discuss today in detail. What we are interested in is the preoperative HTO planning, and there are three famous methods that we can use. So the two methods which basically are the most practical here are Miniachi's method and Dugdale's method. This diagram particularly shows a real size scanogram method, in which the scanogram is printed on a paper, which is a real size scanogram. We particularly make a nick over here, which mimics our osteotomy, and then we bend the paper, or basically bend the paper so as to get an axis which passes through our point. Now, this method, though found to be accurate, perhaps more than navigation method, is not something that we are going to discuss today. We are going to calculate the correction angle and find the wedge length using these two methods. So we're going to start with the Miniachi method. And Miniachi method, there are 2 points that we need to understand, which have to be marked before we draw the lines. The first point is basically the target point, which, as described previously, is the tip of the tibial eminence, and which basically will represent 56% on the tibial plateau. That is our target point through which the weight bearing axis will pass. The second point is something that we call as the hinge point. Now, this is not a random point that I have marked on the tibial surface. It's a point that I'll be describing in detail as we in the further slides. Just remember this point as the hinge point, and in simple words, it is the point at which your osteotomy ends while we actually do the osteotomy. So this is basically the hinge point. After we have marked these 2 points, we have to draw three lines. The first line is the new weight bearing axis that we are going to correct, that will form after we have corrected the deformity. To draw this axis, just connect the center of the hip joint to the target point and extend it below till it reaches the level of your ankle joint. This is the first line. The line 2 that is described here particularly is a line connecting the hinge point to the center of the ankle joint. So this is line 2, and the third line that you need to mark is the point where line 1 crosses the level of the ankle joint and the hinge point. So these are the three lines that we are going to mark, and our correction angle that we have described here as alpha is the angle between line 2 and line 3. Remember that Miniachi method and Dugdale's method are method to find just the correction angle. So for in the Dugdale's method, we are going to Dugdale's method is something that I find relatively easy when compared to the Miniachi method. In this method, we just need to we need to mark one very important point, which is our expected target point, which is again the apex of your lateral tibial eminence, marking 56%. I'm repeating this again and again, marking 56% of your tibial plateau. And after you have marked this point, simply connect the centers of your hip joint and your ankle joint to this point. The angle that particularly is made by these two lines is what we call the correction angle. So it is pretty easy to understand. This is a method that I usually use. I've mentioned Miniachi method because it is the most used method that I saw in research papers. So this is particularly the most important slide that I can offer during this lecture as to why are we even calculating this angle of correction. Now there is example, if in a case we have calculated an angle of correction to be required, that is required is particularly 13 degrees. How can a surgeon who is doing the HTO say that yes, I have perfectly corrected this deformity by 13 degree in intraoperatively? He can There is no particular method as such, but surgeons use this trick where the distraction on the medial cortex is used as a guide to say that yes, I have corrected the deformity by 13 degree. Now this is the where the tricky part gets in, and I was really confused at how do you convert a measurement of angle into a measurement of length. Example, if I have the intraoperatively we use this device which is a distraction plier, and we can see that there are readings here which tell us that yes, the distraction is particularly by of 5 mm or say 7 mm up to 20 mm. So we have these readings here, and how are we able to predict that yes, I have corrected 12 degree by looking at something which are measurements of length. So this is where pre-operative planning comes into action. So after we have calculated the correction angle, what you must do is you must go and mark the hinge point. Now, how do you particularly mark the hinge point? The hinge point clearly lies on the lateral half of the tibial plateau. It is at the level of the apex of the fibula head, leaving approximately 1 centimeter of lateral tibial cortex. So this is particularly the hinge point. After you have marked the hinge point, you have to draw a line which would mimic your osteotomy line. Now, ideally, in a practical scenario, the osteotomy should start 3 centimeter on the medial cortex, below 3 centimeter below the medial joint line on the medial cortex. You have to you have to like roughly mark this point on the scanogram. Example, if we use this, so this is the point at which our osteotomy will start and it will end on our hinge point. So this is line number 1 that we are trying to talk about. The second important line, now we have calculated the correction angle previously using Dugdale's method. An example, if it is 10 degrees. So now using this main line, you have to mark another line which is sitting at an angle of 10 degrees on the hinge point. Say this is this line. So you have nothing but you have replicated the angle of correction on the hinge point facing the medial cortex. Now this length of the medial cortex is, example, if we calculate it and it comes to be 15 mm. So now we can be sure that if I achieve a distraction on the medial cortex of 15 mm, then I am going to correct the deformity by 10 degree. So this is where the trick happens. We put this distraction plier in the osteotomy side, distract it by 15 mm, and this is going to give our ideal needed correction of 10 degree. So this is basically the trick, and this is how we calculate the wedge. So wedges come in different sizes, and it is not necessary that if you have a distraction requirement of 15 mm that you need a 15 mm wedge, because the wedge preferentially goes and sits inside. So this 15 mm is basically the distraction at the medial cortex on the distraction plier that is needed to get the correction of the required angle. So after the previous slide, I think it is very clear why we need to pre-plan the angle that is needed, angle of correction that is needed in high tibial osteotomy. As remember that high tibial osteotomy is a simple limb realignment procedure, and the clinical and the knee preserving benefits of HTO will be achieved only if the exact amount or near exact amount of slight valgus overcorrection is achieved. This cannot be achieved without having a target in mind, say 15 degrees. Now this 15 degrees is converted into distraction at the medial tibial cortex of, say, calculated 17 mm, and hence the calculation is very important so as to mimic a correction of 15-degree practically. So it is the most important intraoperative guide that will help us to overcorrect exactly what is needed so as to get most benefits out of HTO. Obviously, if the varus correction angle becomes is calculated as more than 20 degree, we need to combine HTO with DFO, as a simple HTO won't be able to correct such a deformity without having sagittal plane issues. And obviously, it helps us in logistics as the angle of the mm of distraction that is needed in the medial cortex gives a hint of what size of wedge is required to get that distraction, and hence we should keep that wedge ready intraoperatively. So thank you, and I hope that this lecture has helped you in understanding the basics of planning of the correction angle for high table osteotomy, and now you understand why a faculty is behind you to calculate this angle pre-operatively. You please mention in the comment section as what next orthopedic principle I should be explaining as I would after the high table osteotomy series. I'll be coming with more lectures which dive more into the depth of high table osteotomy as a surgery, and I'd like to leave you all with to read two very interesting papers on high table osteotomy. One is by Professor George Chahla, and second is by a Korean paper by Dr. Kang, and these two papers are something that helped me in understanding what high table osteotomy is, and it will help you a lot if you go through it. Thank you.